This is problem number 5 from section 3.2. In this problem it says find the indicated derivative, and they want us to find dy over dx for this function. So let's use the definition, which is limit as h approaches 0 of f of x plus h minus f of x all over h. Let's go ahead and plug in x plus h into the function, so we end up with equals limit as h approaches 0. We'll end up with 9 over root x plus h plus 8 minus 9 over root x plus 8. And that's going to be over h. Now I'm going to try and combine these together by multiplying these fractions to get a common denominator. So I'm going to multiply by, let's go, limit as h approaches 0. And let's multiply the left one by root x plus 8 over root x plus 8. So we get 9 over root x plus h plus 8 times that fraction minus 9 over root x plus 8. And we're going to multiply this one by root x plus h plus 8 over root x plus h plus 8. So we end up with limit as h approaches 0. This will end up with 9 root x plus 8 over, and actually we'll just kind of combine some stuff together. So this will be 9 root x plus 8 minus 9 root x plus h plus 8. Because the whole reason we did this was so that we had a common denominator we can subtract them together. So this is root x plus 8 on the bottom, and this is root x plus h plus 8. And this is still all over h. Now at this point I think I need to multiply by the conjugate, and maybe I'll wait just a second. Let's go ahead and we know, because we're dividing by this denominator and dividing by this one, that they can be combined together. We could also think of it as putting as over 1 here and then multiplying the bottom by 1 over h and the top by 1 over h. Right, this is just 1, so it doesn't change anything. So we end up with limit as h approaches 0, 9 root x plus 8 minus 9 root x plus h plus 8 all over h root x plus 8 root x plus h plus 8. Now I'm going to multiply by the conjugate. So I'm going to multiply the top by, let's go by 9 root x plus 8 plus 9 root x plus h plus 8. Do the same thing to the bottom. So when we multiply that on top, remember, we still have limit as h approaches 0. On top, we'll end up with 9 root x plus 8 times 9 root x plus 8. Well, that's going to be 81. And then when you take the root x plus 8 times root x plus 8, it cancels the radical, so you're just left with 81x plus 8. Now, I want you to notice that when you multiply this term times this term, you're going to get 81 with the two radicals. This one will give you negative 81 with the two radicals. They're going to cancel, so we're actually going to just skip that step. We're not going to multiply all that out. the whole point of multiplying by the conjugate is to cancel those middle terms anyway. So remember, this times this term is 81 with both roots. This will be negative 81 with both roots. They cancel. So then we just take negative 9x plus h plus 8 times 9x plus h plus 8, and we end up with negative 81. That'll be x plus h plus 8 in parentheses, all over h. We're going to have a lot of radicals here. This is root x plus 8, root x plus h plus 8, and then 9 root x plus 8 plus 9 root x plus h plus 8. So we're going to end up with limit as h approaches 0. Distribute there, we get 81x plus 81 times 8, 648, minus 81x minus 81h minus 648, all over h root x plus 8, root x plus h plus 8, 9 root x plus 8, plus 9 root x plus h plus 8. You can see some things are going to cancel. That cancels here. These cancel. And you're left with negative 81h. So limit as h approaches 0. You end up with negative 81h over h root x plus 8 root x plus h plus 8, 9 root x plus 8 plus 9 root x plus h plus 8. The h's cancel, and you're left with limit as h approaches 0, negative 81 over root x plus 8 root x plus h plus 8. Then you have 9 root x plus 8. And then plus 9 root x plus h plus 8. Alrighty. Let's go ahead and plug in the 0 for h. That's going to cancel here. That'll cancel this. And so we're going to end up with negative 81. And this will give you x root x plus 8 times root x plus 8 inside here. That'll be a multiplication. Roots are going to cancel. You're left with x plus 8. And then inside here we have 9x plus 8 plus 9x plus 8. So that'll be times, this will be 9 and 9 is 18 root x plus 8. So we end up with, well, if we multiply this out, this would be 18 x. So let's go negative, hold on a second. We're going to go negative 81 over 18 x root x plus 8. And then we're going to multiply the 8 times 18. We get 144, so we have plus 144 root x plus 8. we can factor out, what can we factor out of that? 144 divided by 9. So we can actually factor out 18 out of that, 144 divided by 18. Yes, we can. So we're going to factor out an 18 out of this. So we end up with negative 81. Just going to kind of draw a little line there to keep it separated. Negative 81. This will be 18. This will be x root x plus 8 plus 8 root x plus 8. When we simplify here, we can divide them both by 9. And so we end up with negative 9 over 2. And this will be, and we can call it 2x root x plus 8 plus 8 root x plus 8. And that's the derivative for this original function.